In this video, I am going to show you how you analyze the results of TD-DFT or time-dependent DFT calculations. So once you complete your calculation, first open the log file, which I have already done. Then do the right click anywhere on the window, select Results, UV-Vis, and that will bring up a new window showing two types of spectra, UV-Vis spectra and the ECD spectrum. Since we are not interested in the ECD spectrum, I'm going to hide it by doing the right click on the background and selecting Hide Other Plots. So now I'm left with my UV-Vis spectrum. So what do we see here? The black line shows the convoluted spectrum that looks similar to what you would measure in an experimental lab. The y-axis on the left shows the molar absorptivity of the convoluted spectrum and belongs to the black line. The blue sticks show the actual calculated stick spectrum that comes from time-dependent DFT calculation. The unit that corresponds to them is shown on the right, and they are plotted in terms of the oscillator strength for the transition. I can also go ahead and adjust the way the spectrum looks like. So I can do the right click, select the properties. Now, for example, the x-axis by default is shown in nanometers. You can see that I have a lot of white space here on the left and on the right, so I can adjust the range of the x-axis by clicking on Fixed Range and selecting 200 nanometer and going to about 500 nanometers. That's going to cover all of the transitions. I can also change the appearance. So for example, in here I have just calculated singlet transitions. So each of them is labeled as singlet A. I don't really need these labels, so I can go to appearance and I can unclick the checkbox that says, or uncheck the checkbox that says labels. So the labels disappear. I can go back to the plot. Another thing that I can adjust here is how wide this convoluted spectrum is. The default of 0.33 EVs, which shows me the half width at half maximum, is fine for what you will need. But if for some reason you would like to make the spectrum look different, I can change this to, let's say, 0.2, and you can see what's going to happen. Right, my peaks are becoming less fat. So let's go back to the default. Okay. I can also change the unit of the x-axis. Nanometers is fine for the most part. Sometimes you may want to look at the spectrum in terms of EVs. Okay. So now I need to unclick the fixed range so I can see my spectrum. You can see that the spectrum looks different with the EVs because I go here from the lowest energy to the highest energy going from left to right. When I change this to nanometers, I switch the energy. Now I have the lowest energies on the right and the highest energies on the left. So what kind of information I have here with the sticks? So as I select the stick, the information on the bottom changes. So for example, the stick that I have selected right now is at 301.73 nanometers, and the oscillator strength is relatively small, 0.05. And also this is telling me that this is the excited state 4. What is interesting for me is this large stick, which is the excited state 2, that we will need to analyze in more details, and the tiny stick that we can barely see here, which is the excited state 1 with the oscillator strength 0. And If you want to make nice plots from UV-Vis spectrum that you have a little bit more control over, you can also go ahead and save the data in the text file that you can then open with Excel. In order to do that, do the right click, click on Save Data, and then choose whatever the name of the file you want. You can choose where you are going to place it by clicking on the Browse and then click on Save. And I'm going to record another video to show you how you can plot them in Excel.